This is chapter 4.4, the Pythagorean theorem. The Pythagorean theorem is used to find the unknown sides of a right triangle. It's really important you understand it's a right triangle. This is the only triangle it works for. A model of what this looks like is we'll go ahead and go around. This is your original triangle right here. So that right there is your original triangle. So what you're saying is that if I take this side and square it, so this side is 3 and I square it, I get 9, so there'd be 9 squares here. If I take this side right here, which is 4, that's the side called A, 4 squared, I get 16 squares here. Well, if I take and put those two squares together, 9 squares and 16 squares, I get a total of 25 squares. Well, what would this side have to be if I have 25 squares? Oh, it would be 5, because 5 times 5, 5 squared is 25. So here's what the formula looks like. Take your a squared, that's one of your legs, plus your b squared, your other leg. It's going to equal your c squared, which is your hypotenuse. We'll do a picture of that in just a moment. So a squared is 4 squared, b is 3, so 3 squared. So 4 squared and 3 squared, 16 plus 9. And we know that 16 plus 9 is 25. We assumed it would be 5 squared, which is 25, and 25 does equal 25. This is a model of what the Pythagorean theorem looks like. Let's just quickly talk about the vocabulary. Okay, so here's another right triangle, this time without all the modeling on it. This side and this side, the A and the B, which are going to be adjacent to one another, they're adjacent from where the right angle is, are the legs of the right triangle, and the side directly across from the right angle is called the hypotenuse. And the hypotenuse is always the longest side, which makes sense because if you take the square off of this leg and the square off of that leg and put it together, the hypotenuse would have to be the longest side. Okay, you're going to be finding the hypotenuse because the hypotenuse is directly across from the right angle. That's the longest side. So if you took a square off of that, that would be 25. A square off of this, that would be 12 squared, which is 144. So 144 and 25 is what is going to be this square right here. Now let's go ahead and plug that into the formula and we'll see what that looks like. So we're going to go a squared, which is 5 squared, plus b squared. Let's go ahead and write that. And write the formula again. A squared plus b squared equals c squared. So a squared is 5 squared. B squared is this right here, your other leg. They are adjacent sides. Plus 12 squared equals c squared. So 25 plus 144 equals c squared. Now you don't need a calculator for this. If you go 140 and 20, it's 160, plus 5 and 4 is 9, so 169 equals c squared. Now what you're saying is that off of this, c is a square that's 169. So you have to say in your head, what times what equals 169? Well, that's going to be 13. So this side is going to be c equals 13. How do we get there mathematically? Well, to take the inverse of c squared, you take the square root. Whatever you do to one side, again, a property of equality you do to the other side. Square root of c squared is c. Square root of 169 is 13. All you're saying is that if you have a square with an area of 169, its side will be 13. There's no need to estimate on this particular one. Okay, let's go to letter B. You're not always finding a hypotenuse. Sometimes you have to find a leg, so we'll do that one next. And sometimes you're finding a leg, so because the hypotenuse is directly across, so that's your C. These are your legs, 7 and the B. So it's going to be, let's go ahead and write the formula again, a squared plus b squared equals c squared. 7 squared plus b squared equals 14 squared. 7 squared is 49 plus b squared equals 14 squared. 14 times 14 is 196. Now, here's where you have to start doing a little algebra. You got to get the b isolated. So we start by subtracting 49. You're left with b squared equaling. You can go through all the algebra if you wish, or you can just count forward. From 49 to 50 is 1. Then from 50 to 100 is 50. From 100 to 90 is 90. 90 and 50 is 140. Plus 1 is 141. And then you've got to go to 6. And you've got to add 6 on. It's going to be 147. Okay, now 147 is not a perfect square. So when you take the square root of b squared to get b, and then you take the square root of this side, you end up with a non-perfect square. So that's the exact answer, the square root of 147. But you need to know what it's about. So we're going to go b is approximately, there's a little wavy equal sign. You go ahead and we're going to round to the nearest tenth. And when you put in 147 in the square root, you end up with 12.1. Both of these are correct answers. Square root of 147 is exact. 12.1 is approximate. So b is about 12.1. And b equals square root of 147. You could have either answer on these. Okay, now let's go ahead and have you try a couple. So if you get stuck, you can always come back to this page. We're going to go to the next page. You try them on a piece of paper, and that'll be your assignment that you turn in. And then turn the video, then we'll go ahead and correct those. So we'll go ahead and correct those when you are finished. Okay, this is going to be your assignment, number 1, Pythagorean Theorem video. Number 1 and 3 from page 199 you'll do right now, so you'll just pause the video, try it out on your own, including approximating if you don't come out with a perfect square. And then the next two you will do and we will correct in class. So you need to write this on a single sheet of paper, write page 199 on the left, 1 and 3. The 2 problems on the right will just be problems that I have made up. So make sure that you do these, but I do want you to check the first 2, numbers 1 and 3, after you finish. Okay, on number 1, you didn't know what the leg A was, so you went a squared plus b plus 6 squared, which is b squared, equals 10 squared, which is your hypotenuse. A squared plus 36 equals 100. Now you have to do a little bit of algebra, subtract 36 using the subtraction property of equality on both sides. A squared equals 64. In order to isolate A, you have to take the square root of A squared, which gives you A. Whatever you do to one side, you do to the other. Square root of 64 is 8. So A equals 8. Now, on this one, you are finding the hypotenuse, because the hypotenuse is directly across from the right angle. So your A is going to be 7 squared, your A squared. Your B squared is going to be 8 squared, equals C squared. 7 squared is 49, 8 squared is 64, which equals C squared. 49 and 64, just do 40 and 60, which is 100, 9 and 4, which is 13, so 113. You take the square root of 113 equals, equals C squared. To isolate the C squared, you take the square root of C squared and get C, and square root of, take the square root of 113. Now that's not a perfect square, the square root of 113 equals C. That's your exact answer. C equals the square root of 113. But many times we want to know an approximation. So C is approximately, if you put it in your calculator, you get 10.6 if you round to the tenths place. So there's your C. Okay, now we're going to have you go ahead and try your own. Okay, the problems that you're going to need to do on your own will be from page 195, number 9, you can see the picture, and number 15. Go ahead and show your work. Bring 1, 3, 9, and 15 to class. This will be a grade. We'll grade 9 and 15 in class, and then we'll go over it. Hope this has been helpful. You can always go back to the beginning of the video and rewatch if you're having trouble. Make sure you have a calculator, especially for the second one, number 15. You're going to want a calculator for 24 squared.